Okay, so we're going to go into a little bit more detail about the inverses of those trig functions that we were talking about yesterday. We discussed the main ones yesterday, sine, cosine, and tangent, but there's actually a total of 6 different trig functions. And the other ones, so the ones that we haven't talked about yet, those are known as the inverse functions or reciprocal functions. So remember, a reciprocal is when you take a number, like in a fraction form, and you flip it upside down. So when I'm doing the inverse of sine, it would be 1 over sine. And the inverse of cosine would be 1 over cosine. So we have special names to kind of represent those. So the inverse of sine is called cosecant, and they abbreviate that CSC. The inverse of cosine is the secant, which is SEC. And then the inverse of tangent is called cotangent, or COT. So when you're looking at a right triangle, we should actually be able to set up 6 different trig functions. So based on this one here, I've got the 6 trig functions underneath it. When I'm looking at sine, remember sine was, if you think about like your SOHCAHTOA, sine was opposite over hypotenuse. So if I'm looking at an angle, so let's say I was looking at theta here on this picture, so down here by A, the opposite and the hypotenuse side would be what I need to use to set up my sine. So if I want to set up the inverse of sine, I take opposite over hypotenuse and I flip it, I reciprocal. Okay, so it's H over A. So these two are an example of an inverse function because it's got opposite over hypotenuse for sine and then hypotenuse over opposite for the cosecant. The same thing happens then for cosine and secant, where it's adjacent over hypotenuse and then they switch it so it's hypotenuse over adjacent. And then tangent would be opposite over adjacent, cotangent would be adjacent over opposite. So if you can set up these 3, you should be able to set up the other 3 by just taking those original fractions and flipping them upside down. Okay, so let's take a look at an example here. So this says that suppose theta is an acute angle of a right triangle, find the values of the other 5 functions if secant of theta is 5 over 3. What I would do to help you out on this kind of problem is draw a picture to kind of illustrate what's happening first. So let's draw a right triangle here. Okay, we know where the right angle has to be. Now we don't know where theta is, but it just has to be one of the acute angles, so it doesn't really matter which angle you guys put it in. So I'm just going to put theta down here in the bottom right corner of my triangle. So they are giving me secant. Secant is 5 over 3. So if I go back up, and I'm looking at my notes here, secant is hypotenuse over the adjacent side. So they're giving me the hypotenuse and they're giving me the adjacent side. So remember, hypotenuse always goes across from the right angle. So the top number is the 5, which is the hypotenuse. So that's going to go across from the right angle. So I'm going to label that side with a 5. And then adjacent would be the side that's right next to my angle that I'm looking off of, which is the one that's connected to it. So that would be the one in between the right angle and theta there. So 3 is going to be on the bottom of the triangle. So really quick, I want to figure out what the third side should be so that I can set up all of my other trig functions, because I'm going to need to know what that third side is so that I can use it for like my opposite side, and then it's also going to become the adjacent side for other angles too. So in order for me to find that, this is when we talked really briefly yesterday about Pythagorean's theorem, a squared plus b squared equals c squared. We're going to use that real quick to help us find this third side. Remember, c is the only one that really matters here. It always has to be the hypotenuse. So that's going to be the 5. So 5 is going to go in for c squared. And you can put 3 in for either a or for b. It doesn't matter which one you put it in for. So I'm going to just put it for b. So I'm going to put a squared plus 3 squared. Do you guys remember using this formula in geometry? Okay, so what's 3 squared? Good, 9. So I have a squared plus 9 equals, what's 5 squared? Good, 25. I subtract 9. So I have a squared equals 16. And to solve it, I square root both sides. And the square root of 16 is a 4. So that third side is 4. So now that I know all three sides of my triangle, I can set up all of my other functions based off of theta, because now I know the opposite length too. So I already had secant provided for me, so I need to find the other 5 functions. So that would be sine, cosine, and tangent. Then I need to do cosecant, so CSC, and then I need to do cotangent, so COT, because they already gave me secant, so I can skip over that one. Okay, and we're basing everything off of secant, okay? So, off of that theta there. So, sine is opposite over hypotenuse, so opposite of theta would be that 4, hypotenuse would be 5. So we're going to put 4 over 5. Cosine would be adjacent over hypotenuse. It's actually the inverse of that secant function that they gave me. So it's that 5/3 flipped upside down. So it'd be 3/5. Tangent of theta would be opposite over adjacent, so 4 over 3. Can you guys tell me what cosecant would be? Good, 5 over 4. And how about cotangent? Good, 3 over 4. Okay, and you can either be kind of using the definitions I gave you earlier for that, or if you know that like cotangent is the reciprocal of tangent, just take your tangent fraction and flip it upside down to find your inverse. All right, let's take a look at a couple more examples here. This one says, given the triangle shown, find the value of cosine of theta. So theta's down here, kind of bottom right corner. Figure out where your right angle would be. So you have 2 options. You either have the bottom left corner, or you have kind of like the top of the triangle. Think about where those perpendicular sides would be. And some of this is just going to be based on what you think it looks like. I'm thinking the right angle is going to be up here at the top, just because that other angle in the other corner looks a little too narrow for it to be a right angle. Okay, so remember, cosine is adjacent over hypotenuse. So I have the hypotenuse side, that's the 6. The 3 square root of 3 side, that's the opposite side. So the adjacent side is actually not given to me in this problem. So I need to try to find it. So again, I'm going to use Pythagorean's theorem to help me find that third side. Which number are we going to put in for C? Because that's the one that really matters. Good, 6, because 6 is across from the right angle, so that's the hypotenuse. Again, I'm going to put 3 radical 3 in for the B. And that whole thing's got to get squared. So I'm putting parentheses around it and then an exponent. That way I make sure that I'm squaring the entire quantity. And then I have a squared plus that. All right, so let's evaluate here. We've got a squared. So when I square the 3 square root of 3, you have to square both pieces. You have to square the 3 and you have to square that square root. So 3 squared is going to be 9. And then when I square the square root of 3, anytime you square something underneath the square root sign, remember those kind of cancel each other off. So that 3 that's underneath it is just going to come out. So I've got 9 times that 3 that came out. Remember the 9 came from this first 3 here. This one, I had to square this 3. So this is where I got 9 from. And then times this 3 that came out. And then equals 36. So 9 times 3 is going to be 27. So I have a squared plus 27 equals 36. What's 36 minus 27? 9. And what's the square root of 9? 3. So that third side is going to be equal to 3, and that's my adjacent side. So now I should be able to find cosine, because I needed that adjacent side, 3, and now it's over the hypotenuse, 6. Do you guys think I should leave that fraction 3 over 6? Can I reduce it at all? Yeah, what can we take out of both? 3. So I would make sure if your fractions aren't reduced that you do reduce them. So it actually breaks down to 1/2. Now, not all problems will require you guys to find a missing side. Like they might give you everything you need to set up the trig function that you're looking for. But if you need to find the third side, you can always use Pythagorean's theorem to help you out with that. That's why we have it. It's really nice for those right triangles. So if you guys go to the next page, why don't you guys try to set this one up? Given this triangle, find the value of secant. Okay, go ahead and check your work with mine. So you did have to find the adjacent side, because secant is hypotenuse over adjacent, and the right angle is up at the top, which means 17 is your hypotenuse. And you're given the opposite side. You need the adjacent side for secant. So I set up using Pythagorean's theorem here. I put 17 in for C, 15 in for B, and then I had to solve for my other side, A. So I ended up getting 8. So to set up hypotenuse over adjacent for secant, it would be 17 over 8. The last example I want to talk to you guys about today is if they say to solve the triangle. If they tell you to solve the triangle, that means that you need to fill out any angles that are missing and any sides that are missing. So in this case, I'm missing 2 of my angles and 2 of my sides, and I need to be able to find all of that information. So the first thing I'm going to do is just kind of label a couple of things here. For my angles, I'm going to call this one towards the top x, and then the one in the bottom left y. And then for my sides, this one on the left side of the triangle I'm going to call A, and then the bottom of the triangle I'm going to call B. Just so that I know those are the 4 things that I need to find. So then what I'm going to do is over here, I'm just going to write out x, y, A, and B. I'm going to put it in a box here. I have to fill out those 4 answers. I do this so that I have everything written somewhere and I know not to forget about it. Because it happens a lot where you start working through a problem and you think you're done and you forgot to go back and get the second angle or whatever. Okay? Now, one of these angles should be easy for us because there's got to be a right angle in this triangle somewhere. Which one do you guys think is the right angle, x or y? Probably x, okay? Y looks like it's a little narrow for it to be a right angle. So that means x is probably 90 degrees. So now I have x is 90. I have another angle that they gave me, which is 47. Do you guys remember what the angles have to add up to in a triangle? 180. So an easy thing to do is to take 180 and subtract those 2 angles that you know, 90 and 47. Shortcut is to also just take 90 minus 47 because those other 2 angles, if one of them's 90, the other 2 have to be 90 together to get you to 180. Okay, so either way that'll work. How much is that second angle going to be? Good, 43. So there's your y. Okay, we're halfway done. We found our 2 angles. Now let's do our sides. So I'm going to use the 47 and the 15. And let's try to find A first. Okay, so based off of the 47 degrees, A would be the opposite side. And 15 would be the adjacent side. Because where the B is at, that would be the hypotenuse, since that's the side across from the right angle. So I have opposite and adjacent, which is what I'm going to be using, so that would be tangent. So I'm going to set it up tangent of the 47 degrees is equal to your opposite side, which is an A, over the adjacent side, which is 15. This is like what we were doing yesterday when we were solving for missing sides. So I'm going to multiply both sides here by a 15. You're going to need your calculator at this point. You're going to take 15 times the tangent of 47. And we'll have to round. Let's just round to the nearest tenth here. So it would be 16.1. So I'm going to come up to my boxed in area and write 16.1 for A. Now we're going to do something similar to help us find B. So B is still the, like if you're still going off of 47 degrees, B is the hypotenuse side. So I have hypotenuse and I know the adjacent side. So what I could do is set this one up adjacent over hypotenuse, which would be cosine. So we would do cosine of 47 equals 15 for the adjacent side over B for the hypotenuse side. Now this one's set up a little bit differently than that one. I can't just multiply by the 15 and call it good because 15 is not on the bottom of the fraction. Really what I would need to do is multiply by B on both sides, because then it would say B times the cosine of 47 equals 15. But I still don't have B by itself. So what I'm going to do is get rid of that cosine of 47 by dividing that whole quantity to the other side. So to help you guys find B, in your calculators, you're going to be taking 15 divided by the cosine of 47. So I want you guys to do that. and you're going to have to round it. This one's going to need to be rounded to like the nearest whole number based on the decimal that you're going to get. And tell me what number you're getting here. 22, because I'm getting 21.99. Okay, so that the second 9 would round that up to a 0, which then just makes it go up to a whole number. So we would round it up to 22. And that's my last answer that I needed up there in my boxed in piece.